This is Design Safe Radio, where natural hazards researchers strive to make our society more resilient to everything nature throws at us.
Hello and welcome to another episode of Design Safe Radio. I'm your host, Dan Zahner, and today I've got another Oregonian with me today. We've got Diane Moug from Portland State University. We're both in the middle of a heat wave, so iced coffee and fans are the order of the day.
Yeah.
Good to see you, Diane.
Yeah, good to see you too. Thank you for having me. Yeah.
It's gonna be what, like 101 today? Well, let's talk about some cool projects, but first, give us a little bit of 60-second intro, kind of who you are, where you're from, your area of research, and then we'll get into our topics for today.
Sure. So Diane Moug, I'm at Portland State University in the Civil and Environmental Engineering program. I am a geotechnical engineer, and actually I did my undergrad in geological engineering and then my grad studies in geotechnical engineering. So I say I'm a civil engineer, but I don't know anything above the ground. Like I can't tell you anything about concrete or buildings. So geology, geological engineering, geotechnical background. My research and teaching tends to focus on geotechnical site investigation, geotechnical earthquake engineering, liquefaction of fine-grained soils like we have so many in the Pacific Northwest, and mitigation of those soils.
Yeah, it's really interesting. We've had, I think, one of your colleagues on a while ago talking about this. So our wonderful team, Marty and Raquel, will probably put some of that in the show notes. But it's been really interesting since, getting familiar with all the things that go on in earthquake-prone areas like the Pacific Northwest, and then that intersection with some really interesting soil types around Portland. That's a really important area of research. So today, though, let's start off with, you just got a career award from the U.S. National Science Foundation. So congratulations. That's huge.
Thank you.
Tell us a little bit about what a career award means for you and then where you're focusing on for that project.
So the career award for me, I like so many other researchers who get the award, it means that I get to follow through with my vision for teaching and research for the next, well, the award is for 5 years, and then the idea is that I carry it through for the next 10, 20 years of my career and kind of set off down that path. Cool. So it's nice to kind of just get to settle in and focus on implementing that work and implementing those initiatives. The project that I'm focusing on for it, the two parts of it, one is on geotechnical site investigation. How can we do more with the data that we get from site investigation to better understand what's below the ground, what additional site investigation activities would be useful, how they can better inform design and construction of our infrastructure. And then the educational part of it that I'm focused on is community college outreach. Here at Portland State University, at least in our department, there's something like 70 or 75% of our students are transfer students. And so being able to go to those community colleges and reach out to the students while they're there before they made the transfer, let them know about what we're doing, what civil engineering is, what geotechnical engineering is, the types of projects that we work on. We might be able to attract a few more civil engineers into the field. What we're finding is that at the community college level, a lot of folks don't know about all the work that civil engineers do, and a lot of them are just focused on computer science or electrical engineering fields, which are really attractive at the moment. And at least my thought here is that if we go in and we let them know about what we work on as civil engineers, and that civil engineers tend to have very steady, reliable careers. It's a great job market right now, that we can bring in some more civil engineers to our program and into the career field.
Yeah, it's really interesting you say that, because definitely from my experience too of knowing what you and others in the geotechnical field do. I've got a friend of mine who lives out in Las Vegas who does geotechnical engineering, and it's like, oh my gosh, he's got a great career and way big time job security, more work than he'd ever be able to do. So that's really great that you're able to get in the community colleges and let them know that you're doing research and you're looking at the stuff below the soil that doesn't get a lot of attention, but it's very important. Anybody who's putting a building anywhere needs to have a geotechnical review.
Right. And yeah, another kind of sales pitch that I use at community colleges is yes, we work on infrastructure and buildings, but we apply methods from electrical engineering, from computer engineering, computer science. We can apply those methods and developments from all of those fields in civil engineering. And so you get to work on very tangible projects that you're driving on, riding your bike on, living in every day, but you do get to bring in different disciplines that you're interested in to work on them or research
Yeah.
them.
And like a lot of fields of engineering, like my background's mechanical engineering, but I don't really do hardcore mechanical engineering anymore. The mindset really helps a lot. Like I'm, really able to understand things spatially and how things fit together and work. And on the civil and geotechnical side, it's like, oh, you can really learn to pick apart your, the world that you live in, and start to just ask better questions. And it just helps in wherever your career wants to take. Like a geotechnical background is just a fantastic foundation, pun intended.
Yeah.
So that's really, really cool. You're working on, let's back up a little bit. I'm getting over caffeinated and excited about this. So you're focusing on field investigations of liquefiable soil. Can you tell us a little bit about some of those, and how you're teaching about that?
Sure. So I'm not exclusively focusing on liquefiable soils, but they do kind of fall into a group of soils that I'll be focusing on for the research.
Mm-hmm.
So I'm focused specifically at this point on the cone penetration test. So it's a tool that gets used very commonly in geotech site investigation, where you're pushing an instrumented cone down through the soil profile, and it's taking data readings along the way, looking at how stiff the soil is, how much resistance there is to pushing, kind of pore water pressures that develop around the cone, and just all types of different data that you can get from it. And yeah, the data then relates to different soil properties, and it can tell you approximately what type of soil you're in. And a lot of the information that we have from interpreting those data or those cone data come from empirical, like we tested this type of soil and we measured this data or these measurements in the soil. So we start to develop those correlations. But because soil is so varied and there's so many different soil types out there, different geologic origins, different depositional environments, it becomes really difficult to develop correlations for every soil that's out there. So what my research is doing is trying to bring it back to more fundamentals, or other folks are doing the fundamentals as well, but I'm taking a fundamental focus to it to say, how can we get an underlying theory that helps us to relate all these different soil types or data from various soils from the CPT to different soil properties and soil types. And so, yeah, that's the idea behind my research, is to really advance our understanding of the cone penetration test. And hopefully it has some impact, because the CPT is just used so ubiquitously.
It's used everywhere. I mean, from a mechanical engineer's perspective, it's like the Rockwell hardness test. It's like you do it everywhere. Just testing how hard things are. Similar idea. So you measure things like how stiff the soil is, how easy it is to pull apart, like conductivity, water, like all that kind of stuff.
Yeah. Like
wow.
It gives you an indication of shear strength of the soil. It can tell you any kind of stress history of the soil, provides an indication of that, soil type. You can also get like straight shear moduli from the soil. So but for most of those, you have to have tested a very similar soil to get those correlations from it.
Okay.
So, yeah.
So you're kind of bringing in, it almost sounds like, a first principles approach, but with, things like maybe machine learning or, large data models to, interpolate and add in extra data sets to a particular test or something like that.
Yeah. And so bringing in more than just, and part of it is still pushing a cone in various soil types and looking at what the data say. And I plan to do that at a NHERI facility at the UC Davis Center for Geotechnical Modeling, their centrifuge, pushing the cone in different soil types and seeing what the data provide. But then also supporting that with numerical modeling and modeling the cone to see if you start to adjust and change certain soil parameters, assign very fundamental properties to the soil, how does cone data respond? So yeah, intertwining the centrifuge work with that numerical work, and as well as some laboratory work that we're doing here at PSU.
Thanks for listening to today's episode of Design Safe Radio. Be sure to like and subscribe on whatever platform you happen to be listening to this on. It really helps people find our show. Thanks to our amazing sponsors, the National Science Foundation and the NHERI Network Coordination Office, which is award number 2129782. Big thank you to Marty LaChance, our guest booker and topic researcher extraordinaire, and Raquel Ruiz, who is our video and audio editor. I'm your host and NHERI Facility Scheduling and Operations Coordinator, Dan Zahner. We'll see you in the next episode. Until then, stay resilient.